Hi, we're going to talk a little bit about torsion, and particularly we're going to look at some things that will demonstrate torsional deformations, and then also look at some cross sections and which ones are a little bit stronger and stiffer than others and the nature of what's going on there. I have in my hand our sponge beam, right? Remember, it's just a little square cross section made of sponge, and then goes along the length. We've got this longitudinal line right here. We've got these parallel red lines there representing the cross sections, right? And so torsion is twisting this member, right? Bending would be doing this, and elongation or axial loading would be that way. Of course, if we go in compression, the thing buckles on us. So that's why compression versus tension is so important. But back to torsion. Notice what happens here to those red lines. As we twist this, the red lines also warp. That's a pretty big deal. And you're going to see that in our basic modeling assumptions. Now, contrast that with this circular cross section. It happens to be hollow. That's not the important part. It's just circular. Notice here we've got the longitudinal line, and then we've got these little surface squares. And when we now twist this one, notice that that square just becomes a regular parallelogram, right? So that's a pretty big deal here, right? We didn't see that when we twist the square. Those red lines warp, right? And here they don't. Also notice here on the end, when we rotate this, that radial line that's shown there stays straight. Also notice that when we twist it, that longitudinal line wraps around like a helix. Now you get a little edge effects, right? That's the St. Venant's principle thing. We want to stay away from the ends, but in between you got that nice little helical wrap that's going on, right? We're going to be studying these circular cross sections, what happens under torsion, that twisting thing. You want to have some real fun. What you want to do is go get one of these Wacky Fun Noodles or the swim noodles. You can also get pipe insulation at your home improvement store. The pipe insulation is going to actually have a slit right here, right? So it won't be fully bonded all the way around. That's so, of course, you can open it up and put it around the pipe, and it serves as insulation. But for us, it actually would serve as a really great demonstration of what happens if we did cut that along there, we weren't fully bonded, and then what happens when we twist. You should do that for extra credit assignment, right? So let's look at some other structural members. Now, here's the Wacky Fun Noodle in its whole glory, right? The whole big long thing. This is a solid version one. Again, when we twist it, watch those lines in the middle, right? We've got this helical wrapping of the longitudinal line, and those squares become shifted, just sheared over. That's a kind of a key thing, just sheared over. When we have the Wacky Fun beam, right, now it's like a little big reinforced concrete, pre-stressed concrete system there. When we, that's really for bending, not for torsion, right? It's really flexible in torsion, right? That's a kind of a crude example of what we call a Y-flange shape. Here's one. This is a plastic version of that, meant for demonstrations, right? So this is our little Y-flange shape that's made out of plastic. We also have open wall cross sections made out of steel. That's the most common example. This is a C shape. This is actually a light gauge steel shape, right? And here's a smaller version of the same thing. You gotta hold these very carefully. You don't see me twisting them much. Well, if I'm careful, I do, but you got really sharp edges. So you have to be a little bit careful. But notice how that warps when we try to then twist that. There's all kinds of funky things there. And so that's why our study here in the basic course of mechanics of materials is about closed cross sections, right? No warping of the cross section upon rotation, right? Plane sections remain plane is that key idea there. So we won't even study these square cross sections because we get warping right away. Warping, not only what happens to the cross section itself, it's no longer its original shape, but also you notice very easily how it warps in and out of plane of the cross section as well. Okay, so those are just some examples of real torsional deformations. Right behind me are some bolts where you also see this torsional business, right? So here's our high strength bolt. This one's an A490 TC. I don't know if you probably can't really see that, kind of maybe slightly. A490 is a high strength bolt. This is a very large diameter one. This little spline tab here in the end is so that the impact wrench comes along, it grabs a hold of the nut, and then spins the bolt itself. The nut actually stays stationary, so it has a chuck that comes along and holds that, and then it has an inner part that twists that. And then you notice here that my bolt has gotten to the ends of the threads, but if you got your parts in here, comes along, starts clamping it, and then at a predefined torque level, then this will shear off, right? And so this is a A325, so lower strength one that still has the tab on there. This one has been spun all the way off, and it has reached its capacity, right? So that's another real world example of torsion.